Overview. The GNS X is a dual navigation system which allows the following functions to be performed. Generation of flight plans using the Integrated Navigation Database, NDB. Automatic navigation either along a defined flight plan or direct to any point. This function is normally performed slaved to the flight director and autopilot. A flight planning function independent of the currently selected flight plan and navigation facility. Initialization of the Inertial Reference System, IRS. Calculation and display of navigational information. In order to generate an accurate and stable present position, GNS X uses a mixture of sensors to derive a composite position. Sensors. Velocity and position information is derived from three sensor types: Inertial Reference System, IRS, Global Positioning System, GPS, Vortac Position Unit, VPU. Inertial Reference System, IRS. In addition to providing attitude and heading reference, the IRS is capable of providing velocity and position information for navigation. IRS is known as an unbounded sensor, requiring no external navigational aids. It is very useful for short-term navigation, but over a period of hours, the derived position can drift significantly. Each GNS X uses both IRS units that are fitted on the RJ. What description best describes the Inertial Reference System? Global Positioning System, GPS. Each GNS X receives present position from a single 5-channel GPS receiver, which calculates position from the GPS constellation of 24 satellites. A minimum of 4 satellites must be tracked to enable position information to be derived. 3 satellites can be used if accompanied by an altitude input from the ADCs. The GPS sensor is known as a bounded sensor and is not subject to significant drift. The GPS antenna is positioned on top of the left wing. Vortac Position Unit, VPU. Both of the GNS X systems incorporate a VPU which receives information from one of the aircraft's VOR receivers and 5 channel scanning DME interrogators. Each GNS X also uses the other system's VPU. The VPU utilizes distance information from the DME of the station selected on the VHF nav controller. Distance information is also used from the other 4 DME channels, which are automatically tuned by the GNS X. This produces the greatest accuracy. If the GNS X does not have sufficient DME information, it reverts to using bearing and distance information to produce a present position of reduced accuracy. Navigation Management Unit, NMU. At the heart of each GNS X is an NMU, which manages all aspects of lateral navigation. Both NMUs also combine position and velocity information from the 5 sensors to produce a composite position. Part of the combining process involves filtering the best qualities of each sensor to produce a computed position. The short-term advantages of IRS are combined with the long-term position stability of GPS and VPU. Due to the short-term stability of IRS, the GNS X biases the calculated position towards that of the VPU and GPS as flight time increases. The NMU also contains an extensive database of navigational information known as the Navigation Database, NDB, which is updated monthly via a floppy disk. This provides the GNS X with all airports with runways greater than 2,000 feet and their stars and SIDs, necessary navigation aids, and the ability to have operator-generated flight plans. Control Display Unit, CDU. Interface with each GNS X is made using the CDUs on the flight deck. The CDU interface includes an on-off key, a bright-dim key, line select keys, message key and message annunciator, display selector keys, an APHIS key, customer option, cursor control keys, next and previous page keys, character and numeric keypads, enter and back keys, a hold key. The approach and tune keys are not used. Interaction with aircraft systems. Each GNS X interacts with the following systems. IRS. As well as deriving position information to the GNS X, position information is provided by the GNS X to the IRS before it can be aligned. Heading is also provided by the IRS to enable calculation of drift angle. ADC. True airspeed, TAS, is provided to enable calculation of wind velocity. Altitude is provided when required by the GPS. Fuel flow. Fuel flow from each engine allows fuel planning calculations to be performed. EFIS. Graphical representation of the currently selected flight plan appears on the ND. Ground reference points, airports and nav aids may be selectively displayed on the ND. A data field displaying navigational information is also displayed on the ND. DFGS. The flight director and autopilot have the ability to fly a selected flight plan. Summary. GNS X system diagram. Introduction. For the remainder of this module, you will be required to interact with the panels on the screen using the mouse to make your selections. An incorrect selection will prompt feedback to help you. Initialization. With the aircraft stationary, Select both IRSs to Nav to begin the alignment process. Switch the CDU on. The avionic master switches are not required to power the GNS X. The test page appears for approximately 30 seconds. When the self-test routine is complete, the initialization page appears. The display initially appears at full brightness. The bright key is used to dim the display. A parallax adjustment can be made to ensure that the line select keys align with the line select prompts. Bright and Papa keys are depressed simultaneously to select the adjustment screen. The arrow keys are used to set the correct alignment. Pressing Enter completes the parallax adjustment. The message indicator on the CDU and both NDs flash to indicate that a new message has been stored for viewing. Press the message button to view the system message pages. Press the message button again to view the sensor message pages. Press the message button again to return to the initialization page. The date and time should be correct, and the ident should appear as correct for the departure airfield. Use the line select keys to place the cursor over the position field. The displayed position is the composite position when the system was last shut down. If the position is incorrect, it may be corrected by entering the latitude and longitude of the gate position. North, south, east or west is typed first, followed by degrees, minutes and tenths of minutes. Then Enter is pressed. If there is a large difference between the entered position and the computed position, the coordinates will flash. Enter the following stand position. North 53:21.6, West 002:16.4. The flight plan. The flight plan list page now appears. A maximum of 7 pages is available, with 8 flight plans listed in alphabetical order on each page, giving a total of 56 flight plans. Flight plan selection. Each flight plan has a number designated to it. Place the cursor over flight plan number 4 and press Enter to select the flight plan. The flight plan should now be checked to ensure it corresponds to the flight planned route. In this case it doesn't, so we have to generate a new one. Generating a flight plan. Press Flight Plan or Next until the next available flight plan list page appears with vacant flight plan fields. Put the cursor below the number of the last available flight plan. Press Enter to display the flight plan page in order to enter the new flight plan. A maximum of 50 waypoints may be entered per flight plan. Start by entering the airport designator of the departure airfield. In this case, Echo Golf Charlie Charlie. Whenever an airport designator is entered as a waypoint, the option exists to enter the aerodrome reference point, or the position of the various runway thresholds, or the various outer markers. Press Enter, and the ARP will be entered as the first point of the new flight plan. The flight plan as specified in the ATC flight plan, may now be entered. A VOR is entered with its three-letter designator. Enter the designator Hotel Oscar November. The database waypoint page, containing the position of the waypoint, the frequency, the magnetic variation, and the elevation, appears. If two database waypoints with the same designator exist, the entry closest to the aircraft's present position is presented. To confirm that this is the correct point, press Enter. Honolulu now appears as the second point of the flight plan. We can now enter the airway B3 as the next part of the flight plan. Press #Bravo 3 and Enter. Airway B3, page 2 of 3, now appears with our starting point of Honolulu highlighted. Move the cursor down to our exit point of Bravo Papa Kilo using the line select key, then press Enter. If the exit point does not appear on the current page, the next and previous keys could be used. The page automatically changes to Flight Plan, with the route along B3 from Honolulu to Brookmans Park entered. Now enter the destination of Echo Golf Kilo Kilo as specified on the ATC flight plan. The option is again given to select either the ARP or the other database points associated with London Gatwick. Press Enter to select the ARP. The flight plan is now complete and will automatically be stored as one of the 56 available flight plans. Selecting the flight plan. Select the flight plan by placing the cursor over Select and pressing Enter. Alternatively, the flight plan could be inverted to reverse the flight plan for the return flight using the Invert command. The flight plan now becomes the active flight plan. Now, any amendments may be made to it without affecting the stored plan. Entering a departure. If required, a standard instrument departure may now be entered into the active flight plan. Place the cursor over Departure and press Enter. The Departure Echo Golf Charlie Charlie page appears with the cursor over the SID field. Press Back for a list of all available departures. Select Conga 1 Romeo. The cursor moves to Transition. Press Back. Select Conga as the transition. Press Back to view the runways available. Runway 24 is in use, so select Runway 24. The waypoints of the SID are displayed. The waypoint Delta 237 Bravo refers to the 237 radial of the Manchester VOR at 2 DME. A equals 1 DME, B equals 2 DME, etc. Select these waypoints to enter the departure into the active flight plan. Before the flight plan is displayed on EFIS, the initial leg must first be selected. Press Nav to select Navigation page 1. The first waypoint will appear in the Foxtrot Romeo field. Verify this by pressing Enter. The cursor will automatically advance to the second waypoint. Verify this again. The cursor appears over the exfil field. Press Enter to cross-fill to the other system. The GNS X is now ready for navigation. How is an airway entered into the GNS X as part of the flight plan? Planning initialization. The planning functions of the GNS X are contained within the plan pages. For the weight planning functions, the weights of the fuel on board, the aircraft basic weight, the payload, and the reserve must be entered before flight. Plan page 1. Press Plan to enter the fuel status page. The unit of measurement is indicated in pounds or kilograms. Change the units of measurement to kilograms by placing the cursor over pounds and then pressing the back key. Kilograms appears. Press Enter to confirm the change. Kilograms are now the new units of measurement. Place the cursor over 7,968 and enter the amount of fuel on board, 5,500. Enter the fuel reserve of 2,100 and verify the flow as 0. The hours field gives the endurance to reserves. Range and nautical miles per kilogram are not calculated when ground speed is unavailable. Press Back to enter the aircraft weight page. Plan page 6. Place the cursor over the basic operating weight field to adjust the aircraft basic weight if necessary. Enter a value of 25,600. The payload may now be entered. Enter 6,500 in the payload field. The fuel on board value is correct from the entry made on the fuel status page. The aircraft gross weight is now displayed in the gross weight field. The remaining pages of the planning function will be explained later. Preparing EFIS. The takeoff is normally made with the navigation display in the map mode with the scale selected on an appropriate setting for the departure. Select map mode on the format control. Select a range of 40 nautical miles. It is recommended that LNAV is displayed as the primary course and VOR displayed as the secondary course, although this may be changed dependent on the departure being flown. Select LNAV1 as the primary course using the course controller. Press the second course button until VOR1 appears. The GNS X flight plan as entered may now be viewed on the ND. To check the flight plan for gross errors, select the Format control on the EFIS controller to Plan. The flight plan now appears with the active waypoint in the center of the circle. To view the entire flight plan, press Direct and place the cursor over Hotel Oscar November. Honolulu now appears in the center circle. Change the range scale to 80 miles to view the entire flight plan. Select Map Mode on the EFIS control panel and select a range of 40 miles. Repeatedly press the Data button on the EFIS control panel to cycle through ground speed, wind and ETA on the ND. The flight. The SID entered in the GNS X must not be used as a primary reference for navigation. It must be flown with reference to either VOR information displayed as the second course or ADF information displayed either on the ND or DBI. When the SID is complete, the autopilot may be coupled to the GNS X. Note that with LNAV selected as the primary course, the LNAV deviation scale is displayed on the PFD. Press LNAV on the MCP. LNAV now appears as the autopilot lateral mode on the PFD. Direct to. The direct pages contain a listing of all the active flight plan waypoints. The last direct page contains a listing of the 9 closest airports with runways longer than 5,000 feet. Selecting any of the waypoints or closest airports enables navigation direct to that point. Press D. This page enables the selection of any of the active flight plan waypoints for a direct routing. Press D. The last page displays the 9 closest airports. A direct routing to Daventry is given by ATC. Press Previous to display the active flight plan waypoints. Place the cursor over Delta Tango Yankee and press Enter. Notice that a new line appears on the flight plan on the ND from the present position to Daventry. Navigation page 1 appears on the CDU and Direct appears in place of the From waypoint. Navigation pages. There are normally 4 navigation pages, or 5 if AFIS is installed. This module does not cover AFIS. Page 1. Click over each field for an explanation. Page 2. Click over each field for an explanation. Parallel course. Returning to our flight, we wish to fly a parallel track of 5.5 miles to the right of our desired track. Place the cursor over the selected cross-track field and press R, followed by 5 and 5, then press Enter. The aircraft will now turn to the right until the cross-track distance becomes 5.5 miles. Note that cross-track is indicated on the ND. This function is cancelled following a leg change, either along the active flight plan or following a direct to command. To cancel this function, place the cursor over the selected cross-track field and press back. The prompt Cancel appears. Confirm this by pressing Enter. Page 3. Click over each field for an explanation. Page 4. Navigation page 4 is the sensor status page and allows access to information related to all the system sensors as a series of subsections. The position field indicates the current composite position as calculated by the NMU based on data from all available sensors. Below is a list of each sensor with the radial difference between the sensor position and the composite position in nautical miles. Sensor deselection. If a sensor can be positively identified as being grossly in error, its contribution to the composite position may be removed by deselecting it. Place the cursor over IRS-1. Press the back key and the Out prompt appears. Confirm the deselection by pressing Enter. Out remains in the sensor field. IRS subsection, page 1. Place the cursor over IRS-1 and press Enter. Page 1 of the IRS-1 subsection appears, showing the composite position as previously seen on navigation page 4 and the computed position of IRS-1. The difference between the two positions appears in the difference field in degrees, minutes and tenths of minutes. Press either Nav or Next to enter subsection page 2. IRS subsection page 2. Time to Nav appears in minutes when the IRS is in the Align mode. Current mode shows the current mode of the IRS, either Attitude, Align or Nav. Press Nav to return to navigation page 4. IRS-2 subsection is identical in structure to IRS-1. Place the cursor over VPU-1 and press Enter. VPU subsection, page 1. Position indicates the composite position. VPU-1 indicates the position of VPU-1. Difference indicates the difference between the two in degrees, minutes and tenths of minutes. Press either Nav or Next to enter subsection page 2. VPU subsection, page 2. Quality indicates the reliability of VPU data, ranging from 2, the optimum, to 99, dead reckoning. A quality value may be manually entered in the Advise if greater than field to automatically generate an error message if the quality value increases above that limit. We will look at error messages later. Current mode indicates the current mode of VPU navigation. The possible messages are DME, DME. Distance from two different DME stations is being used to calculate positions. VOR, DME. The current method of position calculation uses distance and bearing. Bad geometry. Station geometry is inadequate for navigation. Nav 1 or 2 conflict. The VPU is not using the frequency selected on the nav controller because of a possible frequency conflict with a nav aid within line of sight. No measurements. No valid data is being received for navigation. Press either Nav or Next to enter subsection page 3. VPU subsection, page 3. The station identifier and frequency, and the associated range and bearing from aircraft present position to the station are displayed for the Nav 1 and Nav 2 controllers. Press either Nav or Next to enter subsection page 4. VPU subsection, page 4. The stations which are automatically received by the 4 channels integral to each VPU are called VPU remotes. The ident, frequency and range of each VPU remote is displayed on this page. Press Nav to return to navigation page 4. Place the cursor over GPS and press Enter. GPS subsection, page 1. Position indicates the composite position. GPS indicates the present position as calculated by the GPS sensor. Difference is the difference between the two positions in degrees, minutes and tenths of minutes. Press either Nav or Next to enter subsection page 2. GPS subsection, page 2. GPS GDOP, geometric dilution of precision, is a measure of the quality of the GPS-derived position based on the relative geometry of the tracked satellites. 1 is the optimum value, 99 the least desirable. Satellites in view is the number of satellites able to be tracked based upon records contained within the system. Satellites tracked is the number of satellites the system is tracking up to a maximum of 5. The message Using ALT appears when altitude is required by GPS due to either only 3 satellites being tracked or a high GDOP value and is being provided by the ADC. Press either Nav or Next to enter subsection page 3. GPS subsection, page 3. The GPS status page shows the current status of the 5 GPS channels, channel 1 through to channel 5. The second column indicates the signal-to-noise ratio from 1, minimum usable, to 99, the maximum. Dashes appear if no signal is being received. The third column indicates the channel status. Off, channel off, inactive. Failed, channel off, failure. Sync or search, channel is searching to track a satellite. Track, channel is actively tracking a satellite. The fourth column indicates the elevation of the satellite above the horizon. Press either Nav or Next to enter subsection page 4. GPS subsection, pages 4 and 5. The Satellites page shows the condition of each satellite from 1 to 12 and its status within the GPS system. The first column is the number assigned to the satellite. The second column indicates the status of the satellite. Chan X. The satellite is being received on channel X. Track X. The satellite is being tracked on channel X. Spare. A spare satellite which is in view but not being tracked. Good. Satellite in good health but not in view. Bad. Satellite is in bad health. It is possible to manually deselect a satellite using the following procedure. Place the cursor over satellite number 19. Press Back followed by Enter. Out appears to indicate that the satellite has been manually deselected. Page 5 includes the same data for the remaining satellites. Press either Nav or Next to enter subsection page 6. GPS subsection, page 6. This page displays GPS time. Press Nav to return to navigation page 4. Continuing the flight, press the Flight Plan button to enter the Active Flight Plan. The Active Flight Plan page is used to amend the flight plan by deleting or adding waypoints. Database information concerning any waypoint can be accessed by placing the cursor over the relevant point and pressing Enter. Place the cursor over Echo Golf Kilo Kilo and press Enter. The database waypoint page for London Gatwick appears. It can be seen that the airport identifier, Echo Golf Kilo Kilo, is defined by Aerodrome Reference Point, ARP. The relevant coordinates are displayed. It can be seen that other points exist in the database related to Echo Golf Kilo Kilo. Runway 08 left, runway 08 right, runway 26 left, runway 26 right. The runway thresholds for London Gatwick. The ARP may be replaced by any of these waypoints by placing the cursor over the relevant runway threshold and pressing Enter. Substitute Echo Golf Kilo Kilo for runway 26 left. Adding waypoints. Waypoints are added to a flight plan by placing the cursor over the point which will follow the new insertion and may be one of 3 types. Pilot entered waypoint, database waypoint, offset waypoint. Pilot entered waypoint. A personalized waypoint may be added to a flight plan by entering a waypoint identifier which is not recognized as being contained within the NDB. Place the cursor over Bravo Papa Kilo, type in CBT, and press Enter. The Pilot Entered Waypoint page appears. The position of the waypoint as a latitude and longitude may now be entered in the Position field. Enter a position of North 51 50.2, West 000 22.5 for Charlie Bravo Tango and press Enter. Database waypoint. The identifier of a known waypoint may be entered directly into the flight plan. The database waypoint page containing the relevant waypoint closest to the aircraft present position is displayed. Enter the database waypoint Bravo India Golf after Bravo Papa Kilo on the flight plan. There are 3 waypoints with that designation contained in the database. The closest to us is presented as Database Waypoint Page 1. Confirm this waypoint by pressing Enter. Offset waypoint. The offset waypoint facility allows a waypoint to be specified by a distance and bearing from a parent waypoint. Enter the designator Bravo Papa Kilo Star after Bravo Papa Kilo and press Enter. The offset waypoint page is presented in preparation for input of the offset. Enter the radial of 140 in the radial field and the distance of 10 miles in the distance field. The computed position of the offset waypoint is calculated and its position as a latitude and longitude is displayed in the position field. Confirm this by pressing Enter. Planning, page 1. The fuel status was initialized before flight, based on the amount of fuel on board and the reserve required using Plan Page 1 Fuel Status. This page may be accessed at any time during flight. Fuel flow is automatically sensed from the primary engine display. However, should this indication fail, it is possible to enter a manual fuel flow. Place the cursor over the fuel flow reading and enter a value of 2000. Automatic fuel flow may be regained by placing the cursor over the manual fuel flow reading and pressing Back followed by Enter. Return to automatic fuel flow. Press Plan or Next to enter the Trip Plan page. Planning, page 2. Trip planning is carried out using the Trip Plan page. It allows information to be calculated concerning either the stored or the active flight plan without affecting any of the navigation functions. A manually entered ground speed may be entered in the same way as a manually entered fuel flow was entered on the previous page. The flight plan to be viewed is indicated in the Trip Plan field. When the page is first accessed, the active flight plan, indicated by A, is displayed. Change the flight plan to a stored flight plan by placing the cursor over A and entering number 12. The plan from Echo Golf Charlie Charlie to Echo Golf Papa Foxtrot is now entered for trip planning purposes. Press Enter twice to advance to the next flight plan leg. Press Enter again to sequence through the subsequent sectors. Press Plan or Next to enter Fuel Plan page. Planning, page 3. Fuel planning is carried out on the Fuel Plan page, which operates in an identical manner to the Trip Plan page. Ground speed and flow may be manually entered in the normal way. Press Plan or Next to enter Fuel Flow page. Planning, page 4. Fuel flow for each engine and total flow is indicated in kilograms per hour or pounds per hour as selected on Plan page 1. Press Plan or Next to enter the Date Time Planning page. Planning, page 5. Both date and GMT may be corrected on this page if necessary. GMT may also be changed to GPS time. Place the cursor over the time field and press back. On the prompt GPS, press Enter and GMT is now updated to GPS time. The takeoff and flight time fields appear on takeoff. The land field appears on landing. Press Plan or Next to enter the aircraft weight page. Planning, page 6. This page is normally prepared before flight. However, the fuel on board, fuel used and gross weight fields are constantly updated throughout the flight to reflect the latest weights. Press Nav to enter Navigation page 1. Messages. The message section is divided into the system message pages and the sensor message pages. Indication of a new message is given by the message annunciator on the PFD and the illumination of the message button on the CDU. Press the message button to access the system messages page. Any new message is indicated by an asterisk against the message. Caution messages appear in yellow. System messages. System messages are generated by the NMU and include advisory messages and failure indications. A large number of system messages exist. The following is a summary of the more commonly occurring ones. Press the message button again to access the sensor messages. Sensor messages. Sensor messages describe the status of each sensor. Here is a list of some of the more commonly occurring sensor messages. Pseudo-VORTAC. This procedure gives guidance to fly inbound to or outbound from a waypoint along any selected radial. The selected radial is displayed on the ND and is particularly useful for pilot orientation, either for the inbound course to a holding facility or the localizer inbound course to an ILS. The pseudo-VORTAC is prepared by entering a direct to the required waypoint. We will prepare a pseudo-VORTAC in anticipation of an approach to runway 26 left. Pseudo-VORTAC. Enter direct to runway 26 left. It can be seen on the ND that, as expected, a course is painted from the present position direct to runway 26 left. Place the cursor over the desired track field and enter the localizer course of 262 degrees.